So, we're all starting to use these incredible new AI tools, right? But what you probably don't see is this constant high speed arms race happening just behind the curtain to keep them safe. Today, we're diving into a new framework that thinks about AI security in a totally different way. Forget about building a fortress. Think of it more like a digital immune system that has to learn and adapt in real time.
And this quote from the paper we're looking at really just nails the problem. The more we let these AI tools do on their own, the more autonomy we give them, the juicier they become as targets for attackers. It's a pretty simple equation, really. More power means way more risk.
Okay, so how do you protect these things? I mean, your first instinct is probably to build some kind of perfect, impenetrable shield. But what this paper argues is that that's just, well, it's not realistic. So instead of a static wall, they're proposing something much more alive, a digital immune system. A system that's literally designed to detect, respond, and adapt to new threats at machine speed.
So here's how we're going to break this down. First, we'll get a handle on the unique threats AI is up against and why this is a non-stop race. Then, we'll get into the three key parts of this immune system: the eyes and ears, the brain, and the hands. And finally, we'll see how it all clicks together to create a defense that is always getting smarter. All right, let's jump in. First up, this new kind of threat. What's the big deal? Why is securing a large language model so different from, say, securing your web browser or your laptop? Well, there are a few huge challenges here. For one, the attacks are always changing. You've probably heard of prompt injections, where attackers use these really clever phrases to trick the AI into doing something it's not supposed to. Then there's the fact that the models are non-deterministic, which is just a fancy way of saying you can ask the same question twice and get two totally different answers. That unpredictability makes security a nightmare. And maybe craziest of all, attackers can literally use the AI's own intelligence against it, turning its biggest strength into a vulnerability. And all of this leads to the main event, the race against the attackers. When you're dealing with threats that morph and change by the minute, the whole game boils down to just one thing: speed. To really understand this race, the paper uses a concept borrowed from military fighter pilots. It's called the OODA loop. It stands for observe, orient, decide, and act. It's a framework for making life or death decisions in a split second. And in cybersecurity, the rule is simple: whoever can run through their OODA loop the fastest wins. So here's what that loop actually looks like in the heat of the moment. It all kicks off when you observe a brand new attack out there in the wild. From there, you have to immediately orient yourself, figure out what you're looking at. Then you decide what you're going to do about it, and finally, you act and push out a defense. The entire system we're about to talk about is built to make this cycle happen at a blistering pace. But here's the catch, right? That need for speed creates a massive dilemma. On one hand, you have to move instantly to stop a new attack in its tracks. But on the other hand, if you rush out a fix that's even a little bit flawed, you could end up blocking legitimate users, or worse, breaking the apps that your customers rely on. It is a crazy high-stakes balancing act. So, how in the world do you balance that need for speed with the need for safety? Well, it all starts with what the paper calls intel ops. You can think of this as the eyes and ears of the entire operation. This system is basically a giant information vacuum. It starts with collection, constantly hoovering up data from everywhere: research papers, security blogs, you name it. Then, in the prioritization step, it uses algorithms to score all those potential threats, automatically bubbling up the most dangerous ones for a human expert to analyze. And once a threat gets the green light, that's when things get really interesting. Because this is where the two-pronged defense strategy kicks in. The system creates an immediate fix, like a simple signature to block the attack right now. But, and this is the critical part, it also captures all the data about that attack to train a smarter, more powerful long-term defense using machine learning. It's a real one-two punch. Okay, so you've got all this incredibly valuable training data. Where does it go? Well, it flows straight into part 2 of the system, the data platform. If Intel Ops is the eyes and ears, this thing is the brain. The real power here is just the sheer variety of data it's pulling together. I mean, just look at this list. It's not just looking at attacks. It's crunching customer prompts, public datasets, internal tests, human feedback, all of it to create this single, super high-resolution picture of what's happening out there. But its most important job, its whole reason for being really, is to take all that messy data and create what the paper calls golden labels. This is the definitive ground truth source on whether any given prompt is malicious or totally safe. Having these ultra-accurate labels is the secret sauce to training new defenses that can stop the bad guys without getting in the way of everyone else. So we've got the eyes and ears to spot threats. We've got the brain to make sense of it all. Now we just need the hands. The release platform. This is what's responsible for getting these new defenses out into the real world without, blowing anything up. Which brings us right back to that core problem. Okay, you've trained a brilliant new model on your golden data. How do you actually deploy it to millions of users without risking a total catastrophe? I mean, we've all been burned by a bad software update. Now imagine that breaking a mission-critical AI tool for your entire company. No thanks.
The solution they came up with is this absolutely elegant four-step process. First, they deploy in shadow mode. The new defense runs completely silently next to the old one, so it doesn't affect a single user. This lets them validate its performance on live, real-world traffic with zero risk. Once they know it's safe, they can gradually migrate users over. And the whole time, they keep a big red button to instantly roll back if anything, and I mean anything, looks off. It's brilliant.
Okay, so we've seen the three pieces of the puzzle. Now let's pull the camera back and see how they all work together to create this constantly evolving defense system. And this is the magic right here. This is the payoff. You can see how these three platforms feed each other, creating this powerful self-reinforcing loop. A new threat is found, and a quick fix gets deployed. Then, all the data from that encounter is gathered up, which lets them train and safely roll out an even smarter long-term model. Boom. The entire system is now stronger, and then the loop just starts all over again. The absolute key insight here is that every single attack makes the whole system smarter. Which brings us to the big takeaway from this whole thing. In the age of AI, the best defense isn't some static, concrete wall. It's a living system, one that's built from the ground up to learn, to adapt, and to evolve constantly. And that leaves us with one last really big question. This framework shows us a path to winning the race today. But what about tomorrow? As AI systems become more and more autonomous, moving at speeds we can't even comprehend, can our adaptive defenses really keep pace in this never-ending arms race? That's something we're all going to have to think about. Thanks for tuning in.